the sample mean of a normal population. Our objective, we want to describe the sampling distribution of the sample mean for a normal population. Let's recall a couple of things we already know. We know what a random variable is. It is a characteristic of interest that takes on certain values in a random manner. For example, the number of red lights you hit on the way to work. We know what a distribution is. It is a listing of graph of all possible outcomes of a random variable. We describe distributions in terms of their shape, normal or not normal, their center, and we use the mean, and their spread, and we use the standard deviation. Finally, we know that when we have a normal or approximately normal distribution, our empirical rule applies. 65% above or below between one standard deviation below and one standard deviation above, 95% between two standard deviations, 99.7% between three standard deviations. Now let's lead in with a sense of what this is going to be all about. Okay, let's get myself in here. Fair amount of words. You can kind of take notes on this alongside of it. Suppose we want to determine the mean IQ of all individuals. So we're talking about the population mean, mu. Okay, one approach to determining this is to measure the mean IQ of all individuals. Okay, that's not going to happen. All right, that's both expensive to measure the IQ of everybody. It's going to be time consuming, and it's probably impossible because by the time you get to everybody, you've had people born and you've had people die, so we're always changing things up. Okay, so a second approach, so we're not going to get everybody, we're going to go to a second approach, is to survey a random sample of adults and use the sample's mean, X bar, the sample's mean IQ, to estimate the population's mean, mu. Okay? However, as we know, the samples will vary from sample to sample. One sample's mean would vary from another sample's mean. However, okay, if we do this numerous times, if we take a random sample of n individuals and calculate each sample mean, X bar, okay, because the individuals selected vary from sample to sample, the sample means will also vary from sample to sample. And this tells us, or what happens here is the sample mean X bar becomes a random variable. And as a random variable, it has a probability distribution. And as it turns out, distribution has shape. The shape of the distribution of the sample mean is approximately normal. It has center. The mean of the distribution of the sample mean equals the population mean, and it has spread. Okay, the standard deviation of the sample mean is going to be less than the standard deviation of the population. Obviously, the sample size matters. If you have a smaller sample size, you have more variability. You have a larger standard deviation than a larger sample size. The bigger the sample size, okay, the smaller the standard deviation of the sample mean, okay? So lots of words there. We're going to do an example coming up in just a moment. Let's recap. All those words, a lot of reading there. The mean and the standard deviation of the sampling distribution of X bar, the sample mean. Okay, recap all that stuff. Suppose that a simple random sample of size n is drawn from a population. The mean of the sampling distribution, mu sub X bar, is equal to the mean of the population. That is here in mathematical terminology. The standard deviation of the sample distribution is equal to the standard deviation of the population divided by the square root of the sample size, and that is here. The standard deviation of the sample distribution is equal to the standard deviation sigma of the population divided by the square root of the sample size. The standard deviation of the sampling distribution, mu sub x bar, is called the standard error of the mean. All right, an example in words, then we're going to do an example with some numbers, and we're going to make use of the normal calculator. For example, the IQ scores of all individuals are modeled by a normal random variable with mean mu equals 100. Did you all know that the IQs are all centered around a mean of 100? And the standard deviation, sigma, is 15. The sample distribution of the sample mean, which is x bar, okay, the mean, the sample is x bar, the mean IQ of a simple random sample of 9 individuals is approximately normal. Okay, so we did a sample of 9 individuals. The sample distribution of the sample mean is approximately normal with the mu sub x bar equal to 100, right? Let's go back up to here and see that. Okay, the mean of the sample distribution is equal to the mean of the population. Okay, so x bar is equal to the mean of the population, and the standard deviation of the sample distribution is equal to the standard deviation of the population divided by the square root of the sample size. So standard deviation of the population is 15. 15 goes in the numerator. The sample size is 9. We're going to square root 9 in the denominator. 15 divided by the square root of 9 is 5. And here's a picture of that. Here's my population, okay, and my sample is a tighter, higher curve, but they're both normal. We want to keep that in mind because we're going to use the normal calculator in our example. A lot there, a lot to digest. Let's take a look at it and what it means. Okay, give me a second to pull this example up here. I'm going to make sure that my calculator is ready with StatCrunch. Okay, so the IQ, we're going to do an example on that IQ thing again. The IQ, which is a random variable x of humans, is approximately normal with mean 100 and standard deviation 15. Okay, notice we're talking about the whole population of humans. This is a Greek symbol mu, that's a parameter, and this is the Greek symbol sigma, that's a parameter. Compute the probability that a simple random sample of size 10 results in a sample mean greater than 110. Okay, well, let's see here. We know x is normal because it says so. Okay, so the sampling distribution of x bar, which is the sample mean, is also normal. We need to understand that. We're looking for normality so that we can do things with it. Okay, so to use our normal calculator, we need to come up with the mean and the standard deviation. All right, well, the mean of the sampling distribution is mu sub x bar, and that's the exact same thing as the mean of the population mu, and we're told that's 100. So we're good there. The standard error of the mean, sigma sub x bar, is equal to the equals to the standard deviation of the population divided by the square root of the sample size. Well, that's going to be the 15 divided by the square root of the sample size. The sample size is 10 divided by the square root of 10. We'll put that into a calculator. I went out to 3 decimal places, 4743. All right, so we need these two numbers in order to use in order to calculate a normal probability question. compute the probability. Okay, here's the question. What is the probability? Compute the probability that a sample mean, okay, that is mu sub x bar, is greater than 110. We want to compute that right there. Okay, compute the probability P of, we have a sample mean, mu sub x bar is a sample mean, is greater than 110. Let's take it out. Let's take out our calculator. So I'm in StatCrunch, and I'm going to go to our stat calculators, and I'm going to the normal because we're talking about a normal probabilities. But select normal, and here we have it. Okay, and I'm going to go down to the bottom. Well, I'll tell you what. I'll make sure that you all can see it. There you go. I got my defaults here. Well, we know that our mean is 100. So we're going to go back and type in 100. There we go. Right there it is. We know our standard deviation for our standard error, our standard deviation for x bar is 4.743. 4.743. And we want to be greater than, so I need to change my symbol to the greater than symbol. Okay, I changed my symbol down here to greater than 110. Compute. And the answer comes out to be, I'll shift it up for you. As you can see, that I love how StatCrunch gives you the picture. Here's the mean. You know it's your standard deviation is 15. No, standard deviation for the sample is 4.73, so it's about, right about there. And we're looking at 110, so we're here, and there is the piece that is greater than 110. It's not very much. In fact, it's only 0.017 rounded to the 3 decimal places. Okay, so the probability that happens, come back to here, get the paper lined up for you, is 0. And I think I went out to 4 decimal places on this one. 0.0175. Okay, let's talk about what that means. All right, let's interpret that. Interpret your answer. That says it right here. What does that tell us? That tells us 2 things. The probability of obtaining a sample mean IQ, greater than 110 from a population whose mean is 100 is going to be pretty small, okay? Is approximately 0.02. Obviously rounded that to 2 decimal places, okay? So the probability of obtaining a sample mean IQ greater than 110 from a population with a mean of 100, whereas the population of the mean right here of 100 is pretty small at 0.02. Okay, so another way to speak to this, if we take 100 simple random samples, if we take 100 simple random samples of size 10, right? We're taking samples of size 10, and if the population mean is 100, okay, we have about 2. Okay, the probability is 0.02, but we do it 100 times. We multiply this by 0.02. So note that this is 100 times 0.02. About 2 of the samples will result in a mean IQ that is greater than 110. Okay, so let's recap here a little bit. We used our normal calculator after we came up with our sample and our sample mean and standard deviation. Okay, and we came up with a probability using the normal calculator and StatCrunch, and we interpreted it. The probability of obtaining a sample mean IQ greater than 110, just speaking to this in English, the probability of a sample mean IQ greater than 110 from a population whose mean is 100 is approximately 0.02, rounded this to 2 decimal places. So if we take 100, if we do this 100 times, do the sample of size 10, population mean is 100, then we can expect that we're going to have about 2 of the samples will result in a mean IQ that is greater than 110.